3.8, use inverse matrices to solve linear systems. Now, we aren't going to use inverse matrices to actually solve the linear systems. We are going to figure out how to find an inverse of a matrix, but there's a different method I'm going to teach you to solve a linear system by using a matrix. So, if you have the inverse matrix and you multiply it by the original matrix, it should come out to be the identity matrix that gives you 1, 0, 0, 1, or, whatever. One's on the diagonal. But we're going to look at actually finding the inverse matrix. And so just as a refresher before we jump into these problems, the inverse of a matrix is 1 over whatever the determinant of the matrix is times we take and we swap the top left and the bottom right. So that'll be D, A, and then we make the other ones negative. And then whatever that value comes out to be gives us our new matrix when we do that. So just to have that to reference. Let's start with number 4. We have the matrix -2, 3, -3, 4. And I want to find the inverse of it. So, I have 1 over, what is the determinant of this matrix? -8 plus 9. And then times the matrix. So we swap this diagonal. So this is going to be 4 here, -2 here. And then we change the sign of these. So this is going to be -3. And this, because it was negative, is becoming a +3. So this ends up being 1 times this. So the inverse matrix is 4, -3, 3, -2. For this particular problem, normally there's actually a number here that's not 1, and so we can actually see what happens when we do that, but it ends up just multiplying it by a scalar. Number 6, -7, -9, 2, and 3. So we've got 1 over, what is the determinant of this one?
-21 plus 88.
And then swap, so we've got 3 and -7 on the diagonal. Then we change the signs. This would be +9. This is -2. So this number here is 1 over -3. So I'm just going to write that over here so that, anyways, I should probably do it in a, there. So now I just multiply this times this. So -1/3 times 3 is going to be -1. -1/3 times 9 is going to be -3. -1/3 times -2 is 2/3. And -1/3 times -7 is 7/3. And that is your inverse matrix. Eight. So y'all are going to walk me through this one. 6, -22, -12, and 20. So what do I do first?
Find your, that thing, 1 over determinant.
1 over the determinant. So what would the determinant of this one be?
1 over
minus 264.
plus, because they're both 1 over.
But the formula is minus. So that becomes positive, so it's minus that. Not equals.
Or times 20, 22, 12, 6.
Yep.
20 minus 6.
And so this ends up being, I'm just going to rewrite it over here so I don't have to.
happened to the signs? Or yeah, of those.
What do you mean?
Like the negative signs.
You have to change them. So this is going to end up being, I'm just going to write them and not reduce them at the moment. Negative 20 over 144, negative 22 over 144, negative 12 over 144, and negative 6 over 144. And then, we can reduce those down. But you have your calculator, so you can reduce them that way. So get out your calculator and put this matrix in. I'm going to show you how to do the inverse on your calculator.
The matrix.
So this one, the original problem. All right, once you have that in on your main screen, call up the matrix that you just put it in. Does everybody have that? Are we there? All right, so then over here under the math button, it's hard to see on the screen, but there's an x to the negative 1. You're going to hit that. That means inverse. Hit enter. Now, it gives it to you in decimals, but that's a lot. So I'm going to hit math, and then I'm going to do the dart frac thing that I showed y'all before, and that converts them to fractions for you. And that's your reduced fractions from what we just did. So this reduced ends up being negative 5 over 36, negative 11 over 72, negative 1 over 12, and negative 1 over 24. So now, to show you that this comes out to be the identity matrix, hit the multiplication thing. So don't hit anything other than just hit multiplication. It's going to say your answer, and then it's going to have the little multiplication thing. And then call up matrix A again, like that. And we got the identity matrix, so we know that we, in fact, do have an inverse. So if you ever get a problem that says, show that these are inverses of each other, all you would need to do is take the original and the one that they're saying is the inverse and multiply them, and it doesn't matter in what order. It will always give you the identity matrix if they are inverses. Now, not that you can't do a 3x3 by hand, but your calculator will do the inverse matrix of a 3x3 for you. So number 20, these say to find the inverse of matrix A and then check the result by showing that A times the inverse of A is equal to the identity matrix, and the inverse of A times A is the identity matrix. So 1, 0, 2, 2, 1, 3, 1, 4, 4. So you're going to type that into your calculator and then take the inverse of it. Math.
Yeah, calculator I actually get. Where's that?
So then once you have that, I'm going to show you how to do something so that if you are, because we're ultimately going to do A times A inverse, and then we're going to do A inverse times A. And so you don't want to have to go through the whole process again of doing that. So if you, on your calculator, look at the bottom left above the on button, it says STO and it has a little arrow. And so if you hit that after this answer has come up, that is going to be a store button. That's going to allow you to store that somewhere. And so then you're going to hit second matrix and put it in something other than A. So I'm going to put it in matrix B. I'm going to store that answer in matrix B. And so now matrix B is my inverse of A. Okay. So then to check it and do this part, I can do second matrix A times second matrix B. And I get the identity matrix. And you can just, if you are checking it, you can just put that it ends up being equal to I to show that you checked it. And then we can do the reverse, second matrix B times second matrix A. And again, we get the identity matrix.
How syntax do it?
So was your inverse matrix this?
Yeah.
So you got this. Or, well, what's right here? This is what you got.
Yes.
How do you reset all of your matrices? Like, if I don't want these anymore, how do you just? Like,
You just have to go
reset?
clear them
Okay.
under the edit thing. Alright, so you got that. Then did you store it?
Yeah.
Yeah, it's just. I don't.
So you stored it.
Yes.
And you hit enter.
When I stored it and you hit enter, I got the inverse. Or not the inverse, what's that thing? The cap I.
The identity matrix?
Yeah, I got that right. Get stored. Wait. Oh,
Well, when you did what you originally had, A times the inverse of A, you should get the identity matrix.
yeah. Yeah. Yeah.
So you did get it? Okay. Alright. Now I'm going to teach you how to solve systems of equations. I'm going to do it for 3 equations, 3 unknowns. You can also do it for 2, but 2 is probably faster to just do by hand. So 36, they give us negative 3x plus y minus 8z equals 18. They give us x minus 2y plus z is equal to negative 11. And 2x minus 2y plus 5z equals negative 17. So what we do is basically we make an augmented matrix is what it's called. And so we're going to have a 3 by 4 matrix, and we take the numbers in front of the variables and we put them down, and then the last row, or the last column, I mean, is the solution. So it'll be -3, 1, -8, 18, 1, -2, 1, -11, 2, -2, 5, -17. And a lot of times you'll see a book do it like this, where they'll have the dotted line there just showing that it's the switch to the solution set. So this is our X column, Y column, Z column, and then the answer or solution column. And so what you're going to do is you are going to type that matrix in. Let me know once you have that typed in. Emma, you good? Tristan, you good?
Wait, so it's just the. Wait. Oh, yeah. It's just we're doing the 3 by 3, we're doing the whole thing.
The 3 by 4. I said type in this whole matrix. Alright, so now there is a button that, or well, not a button, but a function called RREF. Okay, so hit math, or sorry, don't hit math, sorry, hit second matrix, then math. And you're going to have to arrow down. Sometimes it's faster to arrow up. So notice there is an REF, and then there is an RREF. You need RREF. Okay, it's called row reduced echelon form. You're going to hit that, and then hit second matrix A. And then you're going to hit enter. And you'll notice the left part of this matrix, okay, looks like the identity matrix. And then this right side has numbers, okay. So this means that, let me write it down. This means, because this is, my first column is my X column, so when X, or this is X, is -2, the second column is Y, so Y is 4, and the third column is Z, and Z is -1. Take this off so you can actually see it. So X is equal to -2, Y is equal to 4, and Z is equal to -1 is what that tells you. But how do I write my solution?
In the ordered pair.
Yeah, order triple for these, but yes. 0, 4, -1 would be my solution to this. And if you go back and you plug these numbers in up here, it will work.
So I got the right answers for like the first 3, but the last row just isn't right.
Yeah.
Mine's like,
I got -104.
I got 10 point something.
For what?
The last row, like all the decimals. I don't know.
Oh, also this is negative. I didn't write the negative. So So then I would go back and look at your matrix and make sure you typed it in correctly.
Oh, it's negative 17. Okay, yeah, that's what it was.
Wait, what?
He had positive 17 instead of negative 17.
I don't even know.
Emma, did you get it?
I can't find the R yet.
So hit second matrix, and then arrow right to math, and then arrow down. It might be faster to arrow up, but I always say arrow down.
And then what did you do that?
And then hit second matrix A, or whatever matrix you put it in. You got it. Christian, you got it. And just so you know, you wouldn't have to write like x equals y equals and z equals. I just did that for reference for you. You would just need to go from the matrix to writing the ordered triple. And a 2 by 2 would be done the same, or not a 2 by 2.
Okay.
Two equations, two unknowns would be done the same way. It would just be a 2 by 3 matrix. And then it would still work the same way, the x column, y column, and then the answer column for that.
Are you sure?
I got the right answer after.
You know, the last quiz, that last question, I did not know how to do it. This makes it so.
The way that I do it on like the test is that I will basically on a non-calculator portion give you a problem that is 3 equations, 3 unknowns, and you'll have to solve it. And then on the calculator portion, you'll have the exact same problem to do it this way. And if I do a different one, then I usually will say, like, on the one that's on the calculator, if you also do it by hand, I'll give you bonus point. So, or 2 bonus points. It just depends on the day. Oh, wait. 40. So I want y'all to try this one kind of by yourself. So 6x plus y plus 2z is equal to 11. X minus y plus z is equal to negative 5. And negative x plus 4y minus z equals 14.
Okay.
And just so I don't forget to say it, if there's ever a term missing, okay, so let's say that x in equation 2 wasn't there and it just said negative y plus z equals negative 5, you would have to put a 0 in for x because that x term just isn't there.
Oh my gosh. That's
So if there's any terms missing, you got to put a 0 in, but these obviously they have them all, so you don't have to worry about it.
That's so easy.
Okay.
All right, what'd you get?
X equals 3, y equals 3,
And you wrote it as an ordered triple, I presume.
Yes.
Or you would, I guess. Yeah. Sweet. Makes sense. Not too crazy.
Smoking
What is it?
Just want to win one.
So
Just
is
one.
is
Just
the
one.
beginning always the same
Oh, yeah.
What do you mean?
for the zeros and the ones?
Yes.
All it is
If it doesn't look like that,
tabulation
something's
quiz.
wrong.
That's all it is.
And I will tell you, oftentimes when people come up to me on a quiz or a test and they're like, this isn't working, it's not giving me the zeros and ones like it's supposed to, they've hit REF instead of RREF. So, yeah, don't do that. All right, your problems 5 and 7 are inverse problems that need to be done by hand, and then 19, 35, and 39 you can do on a calculator.
Can you swipe back up? Because I don't really remember how to do the ones by